Okay, so here's your classwork. So you're going to do number 3, 4, and 5 for me as your classwork. Okay. So your classwork. Okay, so you do number 3. Okay, let's say number 3 and number 4 because of time. Number 3 and number 4. So just do that number 3 and number 4 for me. So your time start counting now, and this is classwork ends in exactly 10 minutes time. No addition. Please control the volume of your side, your end.
The host left the meeting.
I want to make my heart go yori yori. Nobody can do. Hey, can you just shut up?
All right, so I'll return the classwork.
Mute off.
If you are done, send me your answers. You can send me the one you have gotten and proceed to your next one if you like. I'm sure it should have been done by now. Especially for my competition students. Charles Daniel, kudos to you for number 1. That's correct. Velo, your number, what are you sending to me? Your number 1. No, Velo, check your word. Ikeremon, that's correct. Number 1 is correct. Charles Daniel, God bless you. I love you for that. You're representing well. Your number 2 is also okay. Ebenezer Madi, number 1 correct. Number 2, you need it exactly. Oh, Charles Daniel proceeded to do number 5. Okay. I'm not interested in that one, but I'll display the answer later. Anthony Pouye, you didn't factorize your denominator for your number 3. For your number 3, factorize your denominator. Anthony Pouye, you didn't do the factorization properly. Avari, that's lovely. Your number 3 is correct. Benedict, your number 3 is correct. Ikide, your number 3 is correct. Delight, your number 3 is correct. Casey, I love you, correct, number 3. Goroye Paul, that's correct. Send in. Yes, my captain, is she here? AZUAT, I love you for that, correct. My captain present. I'm not seeing anything from her. Somto, Obona, send something to me. Etas, have I received anything from you? Ikele moi, David Ijoma. Tochi, I will not receive. Have I received anything from you? Send. Tolu, I want to see something from you. Delight has completed his task. God bless you. Etas, your number 3 is correct. Anthony Prier, well done. I love that. Kudos to you. You're going to your number 3. So go to number 4. We have 4 minutes to the end of this classwork. Ike Raymond completed his task. That's correct. All right, I'm waiting. 4 minutes to go. Obonna, your number, all right, your number 4 is correct. That's correct. Benedict, you completed your task. Correct. Number 4 is correct. Zina, to everyone, I will not respond to that answer. Zina, we are showing everyone what you just did. So you are on your own. I don't know whether it's correct again. Etas, your number 4 is correct. Etas, your number 4 is correct. Obunna Somto, your number 3. Okay, your denominator, you have not finished it. Simplify your numerator, you'll be able to get the correct answer. David Ijoba, your number, what are you sending to me now, David Ijoba? Okay, whatever number you're sending to me, yeah, I think that's wrong anyway. It's wrong, David Ijoba. Ikide, you have completed your tax. That's correct. Anthony Priye, that is correct. So you have finished your tax. We have 2 more minutes to go to end this correction. David Joman, you are correct with number 4. That answer why I sent to me now is number 4, not number 3. And Kissy just did it now. Complete her tax. That's correct. Zina, number 4, you are making a mistake somewhere in your both denominator, Zina, check. Making a mistake. As you go together, that's correct. That's correct. All right, so I think I can stop here. Tolu, I did not see anything from you. I didn't see anything from Tolu. Tolu, on your video. I didn't see anything from Tolu. Who again did I not see something from? Oba Jane, I didn't get anything from you. Tochi Ray, you are correct with your number 3. DK Raymond, your number 5. Okay, I don't know whether what they're doing is correct. I've not checked the answer, I've not done that one. Oba Jane, I didn't see any response from you. Bokosha, did I get anything from you? I can't remember. All right, so let me just do correction because of our time, so we can proceed. All right, so for those of you who are watching and listening, okay, so this is the answer is actually x minus 3 all over x plus 2 for number 3, and also x plus 5 all over x plus 3. So how do we come about that? Let's look at it together. Okay, so let's look at it together. Then I will proceed to a different stuff after now. All right, so those of you who are still working, just pay attention now. Now for number 3, we are given s squared minus 9 all over s squared plus 5x plus 6, all right? And this your numerator, remember this is difference of 2 squared, factorization of difference of 2 squared. S, which can be written as, isn't that saying, because I have seen this s square here, and 9 is a perfect square, so I can write it as s square minus 3 square, okay, all over s square plus 5x, okay, s square plus 5x, then plus 6. And difference of 2 square for your numerator will give us the first one square, the first one plus the second one, the first one minus the second one. So first one plus the second one, that's factorization of difference of 2 square all over the first one minus the second one. So when you factorize that, of course, you now factorize this your denominator. So you see whether there are common factors. And let me just show you the factorization of the denominator. Just simply, I will erase it, but of course, something you should be able to look at this at your stage now and know what it will look like. Okay, let me go to the other side of the board and do that. So we do it here, s squared plus 5x plus 6, all right? So use 1 to multiply 6, you have 6. Factors of 6 that will go is 2 and 3, because 2 plus 3 is 5, and 2 times 3 is 6. So you're going to have x squared plus 2x plus 3x plus 6. And you now factorize x into x plus 2 plus 3 into x plus 2. All right, so x plus 2 is common and x plus 3 outside. You now take them. So you are going to have x plus 2, which is common, and the one outside, x plus 3. X plus 3. So that is what you should have when you factorize. Okay, and of course, the next thing you do is to cancel out common factors. All right, you cancel out common factors. So what are the common factors now? Expression, interact expression. So this particular one, we cancel x plus 3. All right, so you now have x minus 3 over x plus 2 as your final answer. So final answer give you x minus 3 all over x plus 2. All right, so this is the answer for number 3. Some of us are quickly forgetting what we have learned factorization. I hope the coronavirus pandemic is not making us to just stay at home and relax and forget some of the things we have known. Okay. All right. Let's not be that the rich is getting richer and the poor is getting poorer. Okay. Because I know that those combination students, they are busy. They're always having classes. They are studying because, in fact, I think last 2 Sundays ago, Charles Daniel with some people came to the school to write the Olympiad Invitational, US Olympiad Invitational Mathematics Olympiad. Okay, they came here to write it. So it means that they have been studying. Okay, so you also study. Don't just stay at home and you are doing nothing. All right, so for number 2, I'll proceed to number 2 now. Correction for number 2. All right, for number 2, I'm wiping the board now so that I can take my number 2. Okay, so Number 2 correction, which is number 4 here. We are given x squared plus 10x plus 25 divided by x squared plus 8x plus 25. Okay, so in this one, you have to factorize everything. Okay, if I go here to factorize, let me go to this part to factorize. If I factorize my numerator, I'm going to have factors of 25 that will go is 5 and 5, because 5 plus 5 is 10 and 5 times 5 is 25. Okay, so I'm going to have it as x squared, then plus 5x plus 5x. Okay, splitting the factors of this 25, then plus 25 itself. All right, all divided by, if I take this denominator, which is x squared plus 8x plus 25, the coefficient is also 1. So if you use 1 to multiply 25, you still have 25. And factors of 25 that will go in 8x. What and what? Okay. Is it 25 that I have the 15? Sorry, that's 15, not 25. Here is 15. Okay. That is 15. So factors that will go in 15, what do we have? Here is 15, not 25. Okay, sorry for that. So what do you have? So 15, you're going to give us 5 and 3, because 3 plus 5 will give us 8, and 3 times 5 will give us 15. So you're going to have x squared plus 5x plus 3x, then plus 15. All right, so you now factorize by grouping in twos. So the numerator will give you x into x plus 5. Okay, plus the other group of numerator will give you 5, because 5 is common, into x plus 5, all divided by group of 2, these 2 and these 2, x into x plus 5. Okay, plus 3, 5 is common again, 5, sorry, 3 rather, not 5. 3 is common, 3 into x plus 5. All right. So 5 is common for the two sides, and 5 is common for the denominator, also the two sides of the denominator. So what do we end up having? All right, so we end up having, if we group them together, we're not going to have, in our numerator, let me change the color so that you understand what I'm doing. Okay, I'm now going to have x plus 5, taking one of the group, then bracket x plus 3 plus 5 outside again. Okay, all divided by the one denominator, which is x plus 5, which is common, and x plus 3 outside, x plus 3. And of course, you can cancel out. Okay, when you cancel out common factors, all right, x plus 5, we cancel out, we interact with this x plus 5. All right, so our final answer, of course, you know what it is, x plus 5 over 3. So our final answer now gives us x plus 5 all over x plus 3 as the final answer. All right, so I think that is well explained. All right, so let's look at any question and anybody writing. I want to go to the next thing. All right, quickly. So let's go to our next topic, subtopic now, which is addition and subtraction of fraction. All right, those of you that did number 5, we are correct. Those of you that did number 5, I've seen your answer, you are correct. All right, addition and subtraction of algebraic fraction. This is carried out exactly the same way as in arithmetic by using knowledge of LCM, or what is popularly also known as the LCD, lowest common denominator or lowest common multiple. Take note to combine the LCM as an arithmetic, but keep it as factors. Okay, what do I mean by that? What do I mean by keeping it as factors? Now, under simple arithmetic of numbers, when you have 3 all over 5, okay, plus let's say 7 all over 4, your SCM is going to give you what? We're going to give you 20. So you normally use 20 now. But here I'm saying you should keep it as factors, okay? So instead of keeping it as, instead of multiplying it together as 5 times 4 is 20, what do? We just keep it as separate factors, which is 4 and 5. That will make it easier for us because we are dealing with algebra. So we're going to keep it as 5 multiplied by 4. So this is the way we keep it. With this way, it will be easier because we're not dealing with pure numbers, we're dealing with algebra. So as you can now say, 5 can cancel 5, it gives you 4. 4 times 3, 12, which is something as saying when you have it as 20, 5 going to 20 is 4. So when you keep it this way, you can easily see that this 5 will cancel this 5, the other 4 will remain there and use it to multiply. So that's what here I tell us to keep it as factors because easier kept as factors than when you multiply together because you're dealing with algebra. When you multiply together, you'll be having maybe polynomials and other quadratic equations, which might require you to start dividing again, and that will be a waste of time. So you keep it as linear factors when you find your LCD. Okay, alternatively, you can also unify your denominator if you like. Okay, so let's look at these simple examples. Let's start from simple and proceed to make it complex. Okay, so we're asked to simplify the following. Okay, so I will just quickly, look at, I'm sure that you should be able to do 1, 2, and all that. But let me not assume. So let me take question B first. Let me start from B. A is from 1 is very common. So when you look at this question B, we are asked to simplify this. We should simplify the following. So the LCD is going to give us 12x. Okay, that is the LCD because the x is common for all of them. And of course, the LCM of 4, 3, and 2 is going to give us 12. So you have it as 12x altogether. And 4s going to 12s is going to give us 3 because s will cancel s, and 4 going to 12 is 3 times 9. You have 27 minus 2s going to 12s is going to give us 6. Okay, and 6 times 3 will give us 18. Okay, plus 3s going to 12s is going to give us 4, and 4 times 5 will give us 20. And of course, 20 plus 20 minus 18 is going to give us 2, plus 27 will give us 29. So you have 29 all over 12x. And that is the answer for that, for number B. I hope that's clear enough. Is that clear enough? Okay, for number C, now I'm going to use unification. I'm receiving a message here. Okay, all right. So for number C, I'm going to use, I'm going to unify my denominator to solve question C. All right, let me wipe the board here. So you see how I will do that. I want to use the method of unifying the fractions so that is easy. And of course, once again, when I talk about unifying fraction, I mean when the denominators are the same. Now, when you look at this question C here, all right, which is what I'm solving now, we're told it is 4 all over 2m plus 1, okay, plus 5 all over m plus 2. Now, the LCM, if you want to use the LCM method or the LCD method, it just, the LCM of this is going to be the product of the two of them. Okay, if you want to avoid that, you can also unify your denominator. How do I unify the denominator? Look at this fraction. Look at this fraction here. It's covered that the denominator is 2m plus 1. Okay, while this other one denominator is m plus 2. So if I multiply this fraction by 1, by a modified 1. What do I mean by modified 1? When I have m plus 2 over m plus 2, what is it? 3. M plus 2 over M plus 2, what do you have? 1. Good. So that's what we mean by modifying by 1. So remember, in mathematics, when you multiply anything by 1, you do not change the answer. Okay, so if I multiply this fraction now, by modify 1, which is M plus 2 over M plus 2, it will make M plus 2 to appear down here and M plus 2 appear up. So I will now multiply. So I'm going to write multiply by modified 1. Of course, you understand what I mean by that, though it's not a regular language, okay? So I'll now say multiply by modify 1, okay? Both of them. So while I'm multiplying this particular one, this fraction now, by modify 1, which is M plus 2 over M plus 2, I'll also multiply this other one by modify 1, which is going to give me 2M plus 1 over 2M plus 1, because 2M plus 1 over 2M plus 1 is also equals to 1. So the reason is that I want to unify the denominator so that it will be not easy for me to just add. Okay, so that's the reason of doing that. So you are multiplying, you are trying to unify the denominator. All right, so proceeding, I'm now going to have 4 all over 2M plus 1, which is originally there, then multiplied by M plus 2 all over M plus 2, okay, then plus 5 all over M plus 2, then because of this denominator that is here, I'll multiply by also 1, which is 2M plus 1 all over 2M plus 1. So now what you have now for this other one, you're going to have 4M plus 8. You're now going to have 4M plus 8 okay, divided by 2M plus 1. You can see that, and M plus 2, okay, then plus here will give us, if you multiply your numerator, you're going to have 10M plus 5, okay, all over what? 2M plus 1, then bracket M plus 2. Do you now see that the denominators are not the same? And once you have unified denominator, it is very easy to finish up. You see the method of unifying denominators when you want to add and subtract fraction. The denominators are the same now. So what do you now do? Of course, you finish up here. I'm finishing up here now. So of course, the denominator is the same now. So don't worry about the denominator again. It's the same thing. I'm going to just have 4M plus 8, the first numerator here, okay, plus then the second numerator, which is 10M plus 5, then all over is the same denominator. Since denominator are the same now, I'll just take one of them, which is 2M plus 1 bracket M plus 2. So it's not something, it's not simple as if you are doing 3 all over 5 plus 2 all over 5, which you see it isn't as 3 plus 2 all over 5 because the denominator are the same. So it's something like this because you have a unified, you have the same denominator now. So that is similar thing we are doing. So that's why we try to unify the denominator by multiplying by modify 1, each of the fraction by modify 1. Okay, so now what we have here, and of course, 4M plus 10M will give us 14M. And 8 plus 5 will give us 13. So we have it as 14M plus 13, all divided by 2M plus 1 bracket M plus 2. And of course, we are done. Because when you examine the fraction now, nothing is common again. Nothing can divide. This is, it cannot factorize the numerator. Your denominator is already factorized. Okay, so since it's already factorized, it means that You don't need to start expanding it again. Now, this one cannot be factorized, nothing can divide. So this is the end of the mass. Any question? Any question? All right, I'll take another example. So just write. QC? QC? Who disturbing you? Is it Jassy? She has taken away her video. All right, so can I wipe the board now? Can I wipe the board? Nobody writing, so I can wipe the board. Okay. Someone just sent a message now. All right. Okay, so let's look at let me look at the deep part of the question and see how we do a similar thing also. All right, so I'm also going to give you work to do soon. Okay, so I have question D here. Okay, so question D, I have 4 all over x plus 3y minus 1 all over x minus 2y. Okay, so you can still go the same way. You can say, since they are LCM, you can use the method of finding the LCM or the LCD, or you can still use the method of unifying the denominators. Okay, now for this left hand side of the fraction, okay, the left hand side of the fraction, this side contains x plus 3y, but does not have this x minus 2y. Okay, so of course, for this x minus 2y to appear here, you have to multiply this fraction by modify 1. Okay, that means you must have multiplied up and down together. Remember the principle of both sides. If it's an equation, you have to multiply your left hand and your right hand together, okay, so that you can neutralize the mathematics you are doing. So if it's also a fraction, you multiply the up and down. So it is what we call the up and down principle and both side principle of both sides in the case of an equation. So that's what I mean by modify 1. All right. So you multiply up and down by x minus 2y, so that this x minus 2y will not come under here. And also, when you are dealing with this other y, multiply this one also by x plus 3y, so that this x plus 3y will also appear here. And at the end, now, the two part of the fraction, or if it's a 3 denominators, will all be unified. All right, so I'll now say, for this one, I'll now have it as 4 multiplied by x minus 2y, okay, all over x plus 3y, which is originally there, then multiplied by x minus 2y. And you cannot see that this x minus 2y can cancel this minus 2y, and of course you return back to this, so it is nothing changed. Okay, nothing has changed in the fraction, because if I cancel this expression and this expression, I still have this original one back here. All right, Pray, are you with us? Okay, minus, then for this other one also, 1, it was originally there, multiply. Now I'm multiplying x plus 3y, so multiply by x plus 3y, okay, then all over x minus 2y, okay, which was originally there, multiplied by x plus 3y. So you can also see for this side, this x plus 3y can cancel this x plus 3y, and of course you have x 1 all over x minus 2y, which was originally in the question. So that is what I have done. And by doing this now, if you examine these two fractions now, their denominators are exactly the same. And you just quickly go ahead and add up. So just take the common denominator, x plus 3y, okay, bracket x minus 2y. All right, then of course this one will now give us, expand this, which will give us 4x minus 8y. Then expanding this one also, minus 1 times x. Remember that this minus is not for the first term. Many students normally make mistake there. They think it's only for the first one, is for all of them. Minus 1 times x will give us minus x, and minus 1 times 3y give us minus 3y. Don't make mistake, just multiply the minus only once. Use it to expand the bracket. 4x minus s is equals to 3x, and minus 8y minus 3y will give us minus 11y. So we have 3x. All right, let me change the color to present my final answer now. So I'm going to have 3x, okay, minus 11y, all divided by x plus 3y, bracket x minus 2y as the final answer. And when you examine this, nothing can divide. This one cannot be factorized. The numerator cannot be factorized, and of course, that is where you stop. So this is what we mean by solving to the end. Any question? Any question? All right, so quickly write, and of course, when we come back for our last section, I'll just quickly tidy up something, and I'll give you a classwork once again before the class will be over. All right, so for those of you that will be watching, all right, this is Graceland International School, Port Harcourt.